Alright, today we're going to be talking about tangents and circles and finding maybe missing side lengths or missing angles in some figures using tangents in a circle. So first we're just going to start out with what a tangent to a circle is. Okay, so tangent to a circle, it's actually a line. And if you guys want to look over here at the picture, the line I'm going to talk about there is going to be AB in that picture. And it says that touches the circle in exactly, which is a fancy way to say only, one point. And that point is called the point of tangency. So these look kind of weird, but this line just brushes by the circle and just touches in that one point. The point of tangency there would be P in the diagram. Okay, now when that happens, it's going to create a special property, which we're going to talk about right here. If a line is tangent to a circle, this is going on in this diagram here, then it's going to be perpendicular to the radius at the point of tangency. Would help if I spelled perpendicular right. Sorry guys. Okay, so at that point of tangency, what's going to happen is on either side of this is going to be a right angle. And when you know that, that can help you solve all these problems we're going to work through today. Okay, so assume any lines that appear to be tangent are tangent, and then it says O is the center of each of these circles. Find the value of X, and if needed, we're going to round to the nearest tenth. Okay, so first off, I'm just going to extend this just a little bit. If this line continued here that you guys are seeing, the intention is that's supposed to look like a tangent line. So if I'm a tangent line, that means I'm going to intersect at a 90-degree angle, radius or diameter, same thing. And then all we have here is just the inside angles of a triangle adding up to 180. So I'm just going to grab my calculator real quick. One of the angles in that triangle is 38. The other one, because that's a tangent, is 90, so we just subtract those both from 180. So X in this diagram is just going to be 52. Okay, now this one's a little bit trickier. So what I've got going on here, here's my tangent line. So this is a right angle. Now within this picture, I also have a triangle here. And this is a radius and a radius. So if that angle that's marked is 56, this angle also has to be, because that would be an isosceles triangle. That's going to allow us to find out that central angle there. So just the little orange triangle, I'm going to do 180 minus 56 again. And the leftover is 68. So right in here, this is a 68-degree angle. Okay, now here's what I'm going to do to find X. Just going to look at a couple ways to do this. I'm going to look at this triangle kind of similar to what we did in the last question. That whole thing is 90 right there in the corner. This is 68, and X is going to have to be the leftover from that. So 180 minus 90 minus 68, and we're going to get X to be 22 degrees in that diagram. Okay. Now I actually have two intended tangent lines in this picture. Let me just kind of see if I can extend these a little bit. So pretend that's a nice straight line, and here pretend that's a nice straight line going that way, and they intersect back here. So it would look, if we extended them, it would look something kind of like that. Now this is going to be a tangent. This is also going to be a tangent. And if you guys look at the figure there, what I have is a quadrilateral. And so the inside angles of a quadrilateral are going to add up to 360. So to get X, we're going to subtract the 114 we got in the picture, the two 90-degree angles we get from that being a tangent line. And so here, X is going to be 66 degrees. Okay, now all the problems we just worked through, those were angle measures, and then these three problems are going to ask us to find some segments. So again, if you got a line that appears to be tangent, then we're going to go ahead and assume that's a right angle. Now I'm going to highlight something for you here real quick. We have 8 being our radius, so I would argue this little part right here that's also part of the diagram but not labeled. This would be 8 as well. So let me remove this from the picture. This is 8. 8 and 9 together would add up to 17, and then x, and then we have a right triangle, so we can use the Pythagorean theorem. So 8 squared plus x squared is going to be equal to 17 squared. So I'm just going to grab my calculator. 17 squared minus 8 squared gives me 225, and you guys may not know that off the top of your head, but that is actually a perfect square. So when I take the square root there, don't put the plus and minus because we can't have a negative length, and x is going to be 15. Okay, now this one in the middle is probably going to be the hardest problem we do for the entire unit. Let me draw in a radius, and that's going to connect to that line that appears to be tangent there. So I'm going to go ahead and make a right angle right there. Okay, now here's what I would show you. Here, the distance is x, so any radius I draw in would have that same distance. We're going to do Pythagorean theorem again here, but this question's a little bit trickier because I have here, this would be x, this whole side x, and then 8. I can't actually add those together, so that's going to be an expression. The other side of the triangle there is 12, so we can still use the Pythagorean theorem, but this is going to be a little bit more algebra for this question. So I'm going to go ahead and do the two legs, x squared plus 12 squared, and then the hypotenuse is x plus 8 squared. Now this is where we're going to bring back some skills from Algebra 1. You cannot distribute this exponent to this x plus 8. You have to take and multiply x plus 8 by itself. When you square something, that means we're multiplying it by itself. So whatever your preference is, I'm going to go ahead and do a FOIL on this. Or really, I just think of it as a double distributive property. So x has to get multiplied by both terms, x times x, x squared, x times 8 plus 8x. Then I'm going to multiply 8 by both of the terms. So 8 times x gives me another 8x, and 8 times 8 gives me 64. And almost always you can combine some like terms when you do a FOIL, so I'm going to go ahead and do that here. 8 and 8 will be 16, and I can't combine any other like terms here. Let me bring down what I had up here at the top. This was x squared. Now I have this 12 squared. Let me go ahead and just write that as 144, so I can just go ahead and do the problem. So 12 squared is where I'm getting 144. Okay, now ultimately we want to get x by itself on one side. So honestly, if I subtract x squared, it's actually going to end up canceling out on both sides. So really the equation we're working with is 144 is equal to 16x plus 64. So we're going to subtract 64. Oops. So if I do 144 minus 64, I'm going to get 80. And if you divide 80 by 16, I don't have enough room left on the page, but that's actually going to give you the x value being 5. Alright, and then we have one more. Sorry, let me try to leave the work so you guys can see it. On this last picture, you've got what appears to be a tangent line at point P. I'll pull that down a little bit so you can see it. And this is going to be another Pythagorean theorem. In this case, it's not too bad. So we just have the 5 squared plus the 12 squared equals x squared. So we don't have to FOIL anything here. That whole side is x. This is going to be 25, 144. This adds up to 169, which, again, I don't know if you guys know that, but that's a perfect square. Square root there is 13. I don't put the plus and minus because I'm talking about a length, so we can't have a negative answer there. Okay, now example 1 told us to go ahead and assume that lines that appeared to be tangent were tangent. However, this question does not say that at all. This question asks, is this tangent to the circle? So it also asks you to explain. So if it's tangent, then we would be able to show the angle, I'm just going to write NLM, is 90 degrees. So if it's tangent, that angle right here, I'm not going to draw it in the picture because I don't know, but that angle would have to be 90 degrees. The only way for us to prove that is to go ahead and use our converse to the Pythagorean theorem. So I want to know, is 7 squared plus 24 squared, this is a question I'm asking, if I can show that that's true, then that angle has to be a right angle. If that's not true, then it would not be a right angle and it would not be a tangent line. So let's check this out real quick. If I do 7 squared plus 24 squared, you're going to get 625 here. So I'm seeing if this is equal to the hypotenuse squared. The hypotenuse in that triangle has to be the 25 because that's the longest side. And if you guys see, those do check out. So these are equal, so I would say yes, this is a tangent line here, and the reason is because it satisfies the Pythagorean theorem. If it didn't satisfy the Pythagorean theorem, then we'd have to say no. Okay, I kind of cheated and I wrote down the definition because it was kind of long for the next theorem, so if you want to pause the video, go ahead and do that, write that down, and I will explain it to you. It says, if two tangent lines meet at the same point outside of a circle, the point where my two example tangent lines meet is point B. The distance from any point of tangency, so there's two lines there, so there's 2 points of tangency, one at A and one at C. Those distances from the point of tangency to that outside point is going to be congruent. So what I mean by that, in the picture, if you're looking at it, your point of tangency A to B and your point of tangency other from C to B, those would be the same. So in that diagram, the segment from A to B would be congruent to the segment from C to B. We're going to work on this and some problems here in example 3. So I love to use highlighters on these questions, so feel free if you want to as well. So this point of tangency here, this distance is 5. So outside the circle, same distance from these 2 points of tangency, so that would also be 5. So I'm just labeling that there, and I'm just going to switch colors. So this line and this line meet each other outside the circle here, so if that's 4, that will also be 4. So the corners are going to be the same length. So here I have 3 and 3. Then it says find the perimeter of the polygon there, so we're finding the perimeter going around the outside edge of that. And so I'm just literally going to add up the corners. So I kind of do however you want to do this, but 4 and 4, I usually just put 8 because it's twice. 3 and 3 is 6. 5 and 5 is going to be, well, not times, just plus 10. So I'm just adding up around the outside there. So we're going to get 24. So this would be 24 centimeters. Just our perimeter, so it's just the centimeters. Okay, now the next one, a little trickier. This is 6. All right, so the tangent that also meets at that same exterior point, that would be 6. Now, they give me this entire side here as being 9, so that much of it's 6. So then from that tangent point to this point outside, that has to be 3. Same thing right here. This distance has to be 3, and then it switches over at that tangent line. It's going to give me a different number. So this whole side is 8. I'm going up to that tangent point to 3, so the rest of it has to be 5, and then that makes that 5. So then I'm just going to add the perimeter up. So I've got 6 and 6, I've got 5 and 5, and then I've got 3 and 3. So altogether, this would be 28, and this guy would be inches. And then I've got one more. I don't know if I have enough highlighters for this, but we'll try. Okay, this distance is 6. So to this tangent point only would also be 6. Now, if that whole side is 10, and that much of it's 6, this has to be 4, and this has to be 4. Now, I've got a 5 here, and so to this tangent point, the same one outside, this would be 5. Now, it's telling me in the picture there that whole side is 12, so if that much of it I've colored so far is 5, the rest would have to be 7. So I would add up to 12, and then that corner has to match, so that would also be 7. And we've got a little bit different pink. If this is 7 and that whole side is 11, that has to be 4. and then that would be 4. And then we have all the information I need to get our perimeter. So we got 4 and 4, 6 and 6, another 4 and 4, 5 and 5, and then 7 and 7. So all the way around that figure, going to be 52 feet. Now, example 4 is actually going to be a throwback question to what we did the very first day, but it's a word problem, and so I'm going to kind of walk you through it. It says, how much ground does the tire cover in 7 wheel revolutions? If its radius is 14 inches, if necessary, round to the nearest 10. Okay, so pretend this is a wheel. That looks terrible. And the radius is 14. So if you guys think about a tire rolling, like if I'm rolling this across the paper 7 times and I want to know how much ground am I going to cover, you got to ask yourself, am I talking about the area or am I going to talk about the circumference? And if you think about a wheel rolling around and the distance that you're going to cover, this is going to be the circumference. So 2 pi r. And so if I want to do the circumference of this, it would just be 2 pi times 14, or if I want to simplify that a little bit, I would say 28 pi. That's my circumference. Now, the directions say how many times is it, or how much ground is the tire going to cover if it goes around 7 times. So if the circumference, that would just be going around 1 time, is 28 pi. All we got to do, a revolution just means 1 time around. So if this is 7, to get the distance, I'm just going to do 7 times my circumference. And it does say round to the nearest 10th. And since we're involving pi here, we're going to have to do that. So 7 times 28 times your pi button. This would cover about 615.8 inches. And this is not an area, so it's just plain inches. It's not squared. Okay, and then the second question, little word problem here, says the landscaping company is asked to put fertilizer on a client's circular garden. The circumference of the garden is 68. Okay, so I'm just going to go ahead and jot that down as I go. The landscaping company charges 15 cents per square foot to put down fertilizer. How much will it cost the client to have the fertilizer put on the ground? Now, if you guys think about, if I'm spreading fertilizer over this garden here, I would need to cover all inside there, so we're talking about an area here. Now, the tricky part to this question, they give you the circumference. So let me write down the circumference formula, and I'm going to work backwards here. So the radius of this circle, and this is not going to be a nice number, is going to be 68 divided by 2 pi. And I'm just going to put parentheses around that because that's going to be important when I put that in the calculator. So that's the radius. Now, if I need to find my area, I need the radius, which is why I was finding that. Area is pi times my radius squared. Okay, now my pi's are not going to cancel out there because I have to take care of that squared first. But this is how I would find my area here. All right, now this is really important if you want to type this in the calculator, how I have it here. You have to put parentheses around that 2 pi that I've got on the bottom. Otherwise, the calculator will divide 68 by 2 and then multiply the result by pi, which is not what we want to do. So this is going to give me the area of the garden. Okay, so here's how I'm going to do this. I'm going to type pi. No, I'm not going to, sorry, pi. And then I'm going to multiply. Now, that fraction is going to get squared. So I'm just going to put a little parentheses, 68 divided by. You have to put parentheses around this or it will give you the wrong answer. Put parentheses around the 2 pi, and then I'm going to close the parentheses so it's around the whole fraction. That's going to get squared. Okay, so there's my area. That number is 367. Actually, that would probably round up to the next. So let's just say this is 368 to the nearest 10th. That's accurate. Square feet. Now, that's the area of the garden. says the landscaping company is going to charge 15 cents per square foot. So to get my answer for how much they're going to charge me, I'm just going to go ahead and take 368 times 0.15 because they're going to charge me 15 cents. So $55.25 is what they're going to charge us to cover that whole area fertilizing that garden.